Today we're going to look at 5S, compound interest. This is the last section we're going to go through before our first test. There's quite a bit of stuff on our first test, so you're really going to want to make sure to look back at those bell works and your homeworks and then the review that I'll give you in order to get prepared for that. So compound interest is something that you might have a little bit of experience with. One of the nice things is that the formula for compound interest is provided in the IB formula booklet. So if you look at your formula booklet, I believe this is the very last formula for topic 1. So our first test pretty much covers topic 1 and a little bit of prerequisite, what they consider to be prerequisite knowledge. And so our compound interest formula is here. So I'm going to start by copying that down into the notes. So there's the formula. We call this the compound interest formula. And each letter represents a different thing. It's super cool because in here it tells you what they represent. So FV equals future value, PV is present value, N is number of years, K is number of compounding periods, and R% is the nominal annual interest rate of interest. So let's record that over there and I'll talk about each one. So this is about putting money into account. So PV represents the amount of money you initially you put into the account at the very beginning. So present value, and you can think about this as the initial amount of money. So you take some money, I don't know, $1,000, you put it in a bank account, okay? Now that interest is going to, that money is going to accrue interest as it sits there because the bank is going to do different things with it. They're going to loan it out to other people, right? They might invest it into stocks and they're going to make interest. So that pays back to you. So the rate is the percent rate that you get from this money. So they call it the nominal annual interest. In America, we call it APR, annual percentage rate. Okay, same thing. Nominal annual rate of interest is your R. That's going to be whatever percent they give you. Maybe it's 2% or 3% or 4.5% or whatever it is. That's your nominal annual rate of interest. K is the number of times it compounds per year. So sometimes your interest is applied once a year. So every year they say, here's 5%, and they add it to your account, and that's great. Other times they break that 5% up and give you a little bit every month. So if you get 5% for the whole year, they give you a little bit for each month, and at the end of the year you've got your total of 5%. They might break it up by the week. They might give you interest every week. They might break it down to the day, give you interest every day. I don't know, who knows? They might even give it every minute, okay? But sometimes they take that nominal annual interest rate and they break it down and give you pieces of it throughout the year. And that's where the K comes in handy. We're going to make a list while we're talking about K of common K values. So they might say yearly. So if they compound something yearly, then number of times it compounds per year is 1. If they compound something quarterly, there are 4 quarters in a year, okay? That'd be like each season, I guess. So if they say it's compounded quarterly, that happens 4 times a year. Monthly, there's of course 12 months in a year, so monthly is going to compound 12 times. Half yearly, which I think is a funny way of saying that, will be twice. Okay, twice in a year. Daily, 365. So those are some common K values that you might see. There could be others, so just kind of process through what they tell you and think, okay, how many times would that be in a year? The last two things, N is your number of years. So we take our $1,000, put it into a bank account. It pays an interest rate, compounded a certain number of times a year, and we leave it in there for a certain number of years. So maybe 10 years, and then we take that money out or see how much money's in there. And after this happens, after you take your $1,000 and invest it with an interest rate for a certain number of years, you get a certain amount of money. So this is your future value. That's how much money you then have in your account after so many years of having your money in the account. So let's practice this. You invest $1,000 in the bank for 3 years, and you're paid interest rate of 6.5% per annum, which I think is a weird word. Find the amount of money after 3 years. Annum is just going to be another word for annual. So this, kind of like this up here, nominal annual interest rate. Annum is another word for annual. Okay, so that fits right in here with this. Okay, those kind of mean the same thing. So we're going to plug in everything that we know. We're trying to find the amount of money after 3 years, so we're trying to find our future value. That's the amount of money we have after a certain number of years. So our future value equals, our present value is the $1,000, so we presently start with, times 1 plus, something weird about this formula is that you actually plug your rate in as is, so 6.5%. The reason we plug it in as is they do the divide by 100 for you. So you do not have to convert to your decimal. So this is your percent, this is your decimal. The formula has the 100 in there, so it does it for you. So we can actually just use 6.5 over 100 times K. So paid interest rate per year, per annual, okay, once a year, so 1. To the K times N, we just said K was 1, number of years is 3. If we're careful and we use the correct buttons in our calculator, we can type this straight in. Otherwise, some good places to simplify to make sure you do this right. You could put everything together in here. So 1 plus 6.5 divided by, and 100 times 1 is 100. I'm going to use my fancy fraction. 1 plus 6.5 over 100. I'm going to leave it just so you see, like if it was a times 5, how you could type that in. So that's 1.065. 1 times 3 is 3, and then we can type it straight in. You could also type it straight in from the very beginning. So 1,000 times 1 plus fancy fraction, 6.5 over 100 times 1, oops, to the 1 times 3. So you can type it straight in. You don't have to do any simplifying as long as you're careful. Or you can do a little bit of simplifying and then type it in. So future value is $1,207.95. It's always good to make sure it makes sense, okay? So it shouldn't be drastically larger than your initial amount, but it should be larger because we did earn interest. Let's do another one. Example. So it says calculate the final balance of $10,000 invested at 6% PA. That's going to be per annum, okay, per year, per annual, however you think about it. Compounded quarterly for 2 years. So we're going to plug in everything we know. So we are trying to find the final balance. So we're trying to find our future value, final value, however you want to think about that, FV. Our present value is the amount of money we begin with, which is our $10,000. 1 plus, I'm going to keep going back to that formula and plug in everything I know. My rate is 6%. Remember, you don't have to change it to a decimal in this formula because the 100 is already there. K is the number of times it's compounded in a year. So this one says quarterly, and quarterly happens 4 times a year. To the KN, so K, we just said was 4. N is the number of years, which is 2. We, once again, are very careful in how we type this in. So 10,000 times 1 plus 6 over 100 times 4 to the 4 times 2. And there it is. Our final value, $11,264.93. A lot of times on the IB exam with money questions, they will ask you to round to 2 decimal places, very often, okay? Sometimes they might say nearest dollar, sometimes they might say, nearest cent, 2 decimal places, just depends. So if a question asks you how much interest was earned, so this is how much we started with, this is how much we ended with, so if a question asks, well, how much interest did you make, that's just the difference. So we started with this, we already had $10,000. How much money did we earn, how much money did we make by leaving it in the account for 2 years? So to do that, this orange is dying. We just take our future value minus our present value to determine how much interest we made. So we're looking at the difference of those values. So for how much interest, we take our new amount minus our starting amount, and that's going to tell us the amount of interest we earned, which is $1,264.93. By doing this, by leaving our money in the account for 2 years, we made $1,264. An interest rate of 6% is pretty high, so this probably isn't going to happen, right now, but in other markets, it might. So this is how you do interest. It's just the amount you started with compared to the future value. What's the difference? How much money did you make? So sometimes it's not the future value that you're trying to find, and you're actually trying to find one of your other terms. So let's look at an example where that happens. All right, how much does Helena need to deposit? So this is the question. How much does she need to deposit to collect $50,000? So she needs $50,000. She wants to know how much she needs to put in initially in order to get that out at the end of 3 years, and they give us an interest rate and the number of times it's compounded quarterly. So whenever we look at our formula, we need to ask, well, what value do we need? What value are we trying to find out? So we're actually trying to find out the present value. We know the future value. She needs $50,000. How much does she need to deposit in order to get that back out? So when I use that formula, my future value is the amount that she needs. We don't know the present value, PV. We know the rest. So we know that our interest rate is 5.2% over 100 times. We know it's compounded quarterly. So my K value is 4, and my N value is 3. She wants to leave the money in there for 3 years. So how much money does she need to put in right now in order to get that out? For this equation, this is icky, right? Icky to solve. We do know everything here, so we could type that in. I'm going to solve this 2 different ways. I'm going to solve this graphing calculator, and then I'm going to solve this by hand. I'm going to type in the left and the right side of my equations into my graphing calculator. So 50,000 equals, let's see, PV is what I don't know, so X times 1 plus, and I'm typing in it exactly as it is, 5.2, 100 times 4 to the 4 times 3. And we can find where these two intersect. 50,000 is pretty big, so it's going to be pretty far off of our graph, most likely. We can look at the table. We're definitely going to have to put in quite a bit of money. I don't know if the table is the best method. If we start with $5,000, so if our present value is 5,000, nope. So right, we'll probably have to put in like 40,000. Closer. What if we put in 45,000? Well, okay, a little bit closer. All right, I'm trying to see over here where my 50,000, where they're the same. Okay, it's quite a bit less than that. Maybe this isn't the best method. Maybe we find a different method. So how about we find a different method? Let's go to our graph. It's definitely off the graph. So if we look at our window, I need my y to get very big. I need to get up to 50,000. So how about we do 55,000? And my calculator might get a little mad. My x is probably also going to have to be pretty big. And it might take it, oh, that one didn't take a long time. There, this one, there it goes. So you might have to guess around with your window for a while, and that's totally fine. But we need to find where they intersect. So second, calculate, intersect, enter, enter, enter. Okay, there it is. So using the calculator, we get a present value of $42,820 and so 9.8. Yeah, okay, we'll just do 1. That's what we get using our graphing calculator. Does that make sense? Does it make sense that you need to deposit $42,821 for 3 years in order to get 50,000 out? Seems like it. These aren't too far off. Okay, they're pretty close to each other, so that does make sense. Mathematically, for this type of problem, we can actually type in all of this, the 1 plus, exactly as it is, 5.2, 100 times 4 to the 4 times 3, and get a value. Can't always do this. Sometimes we're going to be stuck with that graphing calculator method. And I'll show you an example. The next example is like that. Present value times 1.167651776. And since it's present value times that, we divide it off. So we take our 50,000 divided by that number. Same thing. But remember, keep in mind that whenever you are solving an equation and you look at it and you go, I don't know how to solve that, or even, I think I might know how to solve that, but I think I might make a mistake trying to solve it, then think about your graphing calculator methods. Okay, let's do one last example. I'm going to give you the values and tell you what we're trying to find. So there's our list of values for the formula. We start out with $1,000. It's 4% interest, compounded 12 times a year. We want to get $2,000, but we want to know how many in years. How many years does it take to get $2,000 out? So let's plug in everything we know to our formula. So my future value, we know that, 2,000. Present value, 1,000 times 1 plus our rate, 4%. 100. K is 12. K goes up here also, but we don't know our number of years. So we have a lot of information here, we just don't know our number of years. You guys don't quite have a strategy yet for solving for a variable that's in an exponent. We don't cover that in Algebra 1. We don't cover that in geometry. So we don't have a strategy yet. But our strategy for this class involves the graphing calculator. So let's do what we just did for the last problem, but with our new problem. We're going to type in the left side of the equation, 2,000. Type in the right side of the equation, 1,000 times 1 plus 4 over 100 times 12 to the 12x. That's where our variable is. Graph it. I'm still on that other window, so I'm probably way zoomed out. So we can go back to standard. I don't think that's going to help us much. This means it's thinking, in case you're wondering. That's why I pause, because it's currently thinking. Okay. So we could try zoom out. See if that helps us. It doesn't seem to be helping us yet. So I do know that I have a 2,000 here, so I need to get my y values up to 2,000. So I'm going to try to do that. Before we do that, though, let's try the table method. Table set. Let's go back to 0. So we're trying to figure out how many years until we have $2,000. So somewhere between 17 and 18. At year 17, we're just shy of 2,000, and at year 18, we're just over 2,000. So somewhere between year 17 and year 18, we end up reaching $2,000 in the account. This is the values of how much money is in the account. We want to figure out when it's equal to 2,000. To get in a precise number, we're going to need to get our y values up to 2,000. See if that helps. Barely. I think it's close enough that it'll work. We'll let this graph. If my number is not between 17 and 18, I've messed up. So second, calculate, intersect. Over there is where they're intersecting. 17.3575, there it is. So how many years does it take? N is 17.35, so how about 4? So in those circumstances, it's like how long does it take to double your money to get from 1,000 to 2,000? It would take 17.4 years. All right, thank you for watching. This is your last homework assignment for this unit, and I'll give you your review for the test, and that's where we're at. As always, stop me if you have questions. Call me over. I'm happy to help however I can.